Hi everyone, we are going to take this next section, 6.6, and we are going to divide it in half. We're going to deal with just 2 problems today, and then we'll finish the rest of this section next time. This is all about performing operations with functions. So in other words, instead of taking numbers and adding them, or subtracting them, or multiplying, or dividing them, we're going to take entire functions. We can take one function and add it to another function. Or we can take one function and subtract it from one, or take 2 functions and multiply them by each other, or divide them by each other. So the basic math operations, addition, subtraction, multiplication, and division, applied to entire functions. That may sound complicated, but when we walk through it, you'll see it's not so bad. Let me show you the notation for how to designate what we want to do, and that's what I've written on the board. If I have 2 functions, one's f of x and one's g of x, if I write this f plus g of x, then what I want is I want f of x plus g of x. That's what this means. Take those 2 functions, add them together. If I go f minus g of x, that means f of x minus g of x. Or I could reverse it. If I go g minus f of x, then it's g of x minus f of x. Okay? F times g of x is f of x times g of x. And then the last one is f over g of x, means that f of x divided by g of x. So this looks like one over the other, and then simplify. You have to be really careful with this one because you can never have a denominator equal to 0. So this will automatically exclude anything that would make g of x equal to 0. G of x cannot be 0. So we'll talk about domains and limits to domains when we do this, as we work our way through it. But this is the way to notate the different operations. So let's say f of x is 4x plus 7, and g of x is the square root of x plus x. What would be f plus g, and what would be f minus g? And what would be the domains of both? So really perk up when we start talking about domains. First, let's find the answers to these, and then I'm going to discuss the domains aspect, because that's pretty important. So for f plus g, you just take this plus this. So it's 4x, I'll write it out just so it's clear, 4x plus 7, right? Plus square root of x plus x. So combine like terms. I have 4x's here plus 1 more. I have 5x. I have only 1 positive square root of x, and I have 7. There is my f plus g. So there's my answer for f plus g of x. So I could say f plus g of x equals that. Now when you do f minus g, watch your subtraction. Remember, this entire function is going to be subtracted, but I do the same thing, this minus this. So I have 4x minus x. This is going to be a 3x. And now I'm taking away square root of x, but I'm not, this is 7 minus 0, so this is still positive 7. There is f minus g of x. Now let me talk about domain. If I look at this f of x, is there anything that limits what my x could be? And I can't see a thing. My x would be all real numbers. There's no limit to what I can make my x. So that's all real numbers. But if I look at my g of x, I have this root. And when you have a square root, we are not going to deal with negative square roots. We're not going to deal with imaginary numbers. So therefore, my g of x is limited to everything greater than or equal to 0. All non-negatives. Now because, does that make sense how my domain is limited? I can't have x be a negative number because that would give me a negative square root. Are you good? So g of x, my domain is just 0 and greater. So when I combine them, my domain is limited by this. So the domain of both of them is x has to be greater than or equal to 0, and that is because of this. It affects both of these equations. So bear domain in mind, it's pretty significant. Okay, let's practice adding and subtracting one more time with two different functions. Now my f of x is 2x squared plus 8, and my g of x is x minus 3. So I'm going to do the same thing. I'm going to add f plus g, and I'm going to subtract. I'm going to go f minus g, and then I'm going to list what's the domains of both of these. So in this one, I'm going to take this plus this, which basically just means combine like terms. So I have no x squareds here, so I'm going to have 2x squared, and I have no x's here, but 1 here, plus x, and 8 minus 3 is plus 5, and there is f plus g of x. Just combine them together. Now f minus g, I'm going to take these, and I'm going to subtract these. Watch your signs. So there's no 2x squared minus 0 is 2x squared. 0 minus x is negative x, and 8 minus a negative, careful, 8 minus a negative 3 is positive 11, and there is f minus g of x. Now the next question is my domain limited? What is my domain? What can my x's be? Or even better, what can my x's not be? If you look at f of x, is there any limit to my x's if all I'm doing is squaring them? And the answer is no. X can be anything. So this domain is all real numbers. In this one, we just have a single x. We're not dealing with a root. We're not dealing with division or anything weird. So this can also be anything. So we realize then that our domain for both of these operations is all real numbers. No limits to my x's. So just write all real numbers. Okay, so we practiced adding and subtracting. Let's move on to multiplying and dividing and see how that works with different functions. I have two different functions now. F of x is x squared minus 9. G of x is x plus 3. So I want to multiply this is f times g of x, which means I'm going to go f of x times g of x. Since these are both binomials, the easiest way to do that would be to FOIL. So let me just go ahead and write x squared minus 9 times x plus 3. And I'm going to go ahead and FOIL these two. This is x cubed. This is plus 3x squared. This is minus 9x. And this is minus 27. And that's my answer for f times g of x. Okay, the domain of f of x is all real numbers. There's no limit to what we can make x. So this is all real numbers. Same thing with g of x. So the domain of this operation is all real numbers. No limit. X can be anything. So you would write domain equals all real numbers. Okay, let's look at what division would look like. This is f over g of x, which basically means f of x divided by g of x. And the way to do that is to actually just put f of x over g of x, just like this, and then simplify. So f of x is x squared minus 9, and g of x is x plus 3. So in order to simplify that, I am going to factor x squared minus 9. That's a difference of two squareds, so this is going to factor to be x plus 3, x minus 3. So here's f of x over g of x in factored simplified form, and hopefully you can see that I can cross cancel, or not cross cancel, just simplify by canceling out my x plus 3's. So my final answer is x minus 3, and that's my answer. The last section though is, what about my domain? And remember, when you have division, x can never ever be anything that would enable the denominator to be equal to 0. And that's at any point, even if it's canceled out, it still has to be listed as out of the domain. And if you realize this, x cannot be negative 3, because if x is negative 3, I've got a denominator of 0, which just crashes the whole world. It just does not work in math. So my domain is all real except x cannot be negative 3. Normally, if you just wrote x cannot be negative 3, That will be enough for me when you give me the domain of a problem like that. So here's my answer, and there's the limit to my domain. Okay, let's practice this with a couple of functions that look a little more complicated. This f of x is 3x squared minus 11x minus 4. G of x is 3x plus 1. We're going to start by going f times g. When I multiply a trinomial by a binomial, I set it up just like this, like you used to do division of big numbers in elementary school. First, I multiply all this times 1. Then I multiply each of these by 3x, combining like terms and adding. So watch me go through this kind of fast. So this is negative 4, negative 11x, and positive 3x squared. Now I'm going to multiply by x. This is negative 12x. This is negative 33x squared, and this is positive 9x cubed. Now I add that together and I get 9x cubed minus 30x squared minus 23x minus 4, and there is f times g of x. Now before I erase this, we need to answer our domain question. Is there anything that limits the domain in either one of these functions? And there isn't. Square roots are a big thing, and also fractions are another thing that can really limit your x's, but we don't have any of those situations, so the domain for this is all real numbers. Now I've set up my division, 3x squared f of x minus 11x minus 4 over 3x plus 1. To simplify this, to divide, I need to factor this. So I'm going to do my factoring. 3 times negative 4, that's negative 12. Factors of negative 12 that add up to negative 11 would be negative 12 and 1. Rewrite this. So this is 3x squared minus 12x plus 1x minus 4. And now factor by grouping. Hopefully this is coming back. So factor out 3x. I'm left with x minus 4. Factor out positive 1, I'm left with x minus 4. So my two factors are 3x plus 1 and x minus 4, and I am going to replace this with this. Now when I divide, I simplify. These two cancel out, and my final answer is x minus 4. The only thing I have to worry about is my domain. Remember, this denominator can never be equal to 0. So to find what x cannot be, you can say, what would x have to be for this denominator to be equal to 0? And that's what it cannot be. So my domain is x cannot equal negative 1/3. Please do not forget to show the limitations of your domain. Okay, the last thing I want to leave you with is your lesson check for today. We're going to go back to subtraction. F of x is 3x minus 2. G of x is x squared plus 1. Would you please bring to me tomorrow your answer when you go g of x minus f of x? And also let me know any domain considerations as well. And that's all for this section. We'll finish this section next time. So I'll see you then.